with a, he said it, with a female protagonist. Right. So thank you, Orko. Thank you, data scientists. Better luck next time. But instead of this finite list, what if I gave you the actual movie database? Can we move to the next slide? Sorry. Yes. This is a snapshot of the actual movie database in Rotten Tomatoes. Can you humanly pick out movies for Orko from here? Even if you know this thing. I mean, tomorrow Orko might suddenly think that Game of Thrones is interesting. It's got a female protagonist, but it's also got Jon Snow. So what then, right? That is the idea behind recommender systems. Now, there are good recommender systems, there are bad recommender systems. So I want to warn you before we move any deeper about what a bad recommender system can be. 2 years back, I was playing cricket, and I wanted to buy a pair of Oakley sunglasses. Those of you who are into sports will know what Oakley is. And I went online, I won't name the website, to find it. And since then, this is 2 years back, since then, on every page I visit on Google Chrome, Facebook, LinkedIn, whatever, I see that same pair of sunglasses. I never bought it from them, but I still see it there. The same pair. It's probably even outdated. But that's a bad example. But there are several very good examples in the industry, and we'll cover quite a few of them. With that, let's dive into the subject, and Orko is going to walk you through the next section.
Thank you, Abhi. So yes, as some people have correctly inferred, I'm straight and I like women. Thank you. But yes, as also Abhi brought up the point that, you know, very soon this problem explodes to a position where it's no longer humanly possible. And specifically today, in the era of internet content explosion, not only is it impossible for you to recommend something for me, it's even impossible for you to find something that is relevant for yourself. Think about the amount of content we have on the internet today, be it in the form of blogs on WordPress, photos on Flickr, videos on YouTube, posts on Facebook and Twitter. I'm not even going there, okay? It's just not possible for you to, you know how to direct your attention. You have only 24 hours a day. So what consumers and companies alike are increasingly relying on are these smart systems, computers, machines, working on the background, which direct people towards the kind of content that they believe will interest them, engage them, push them to make the next purchase, and so on and so forth. So there are various aims of using recommender systems, obviously. For the audience over here, it is finding interesting content, obviously. But in addition to that, it also has a lot of important market value. This is coming from more commercial industry company perspective. We have put up some numbers over here, both from the industry as well as some of our project work. I'm not going into every one of them, but you can see the numbers stand for themselves. 75% of what people watch on Netflix is actually what the Netflix system recommends to you, or at least one of, you swipe through it. Would you like to watch this, this one, right? So basically, good recommender systems, intelligent recommender system that makes good recommendations, good citations for you, are driving business and customer engagement throughout the internet space. And therefore, recommender systems are indeed one of those cornerstone technologies that on which the internet, e-commerce, internet content is increasingly reliant today. Of course, recommender systems have existed for a while. We started, I think, somewhere in 1970s or something, where the technology first started coming up. But early 2000s, something happened when people took a lot of interest in recommender systems. So Netflix hosted this competition they had their own algorithm, right, which tells you, here's the next movie that you should watch. But what they did is they reached out to the data science community and they said, can you better our algorithm? Can you find a way by which the recommendations improve by 10%? If you can, here's $1 million to take home. If 10 of you get it, then I'll give it to the best one. Okay? So, two things. Number one, obviously, it engages the curious-minded, the academic-minded, whatnot. But not just that, even competitors and related industries started to take up and take notice of the fact that if Netflix is paying $1 million for this, there's got to be a big deal. Something important, and we should be following it, getting on the bandwagon, whatever you do, right? So here I have put up a toy problem, and probably I will ask one of you to make a guess. Here are 5 users, right, trying to watch through 4 movies. The numbers that you filled over here, they are the ratings that they have provided for the movie. Scale being 1 is awful, 5 is awesome. Okay, and as you can see, there are gaps in the data. This basically means the person has not watched the movie. For now, let us assume it's not a case where the person has watched the movie but not rated it. Just assume they have not watched it, right? So the task of the algorithm is to come up with a recommendation in terms of what will be the expected rating when person X watches movie 1. If you find a very high rating, well, this is the movie that I should push on his face the next time he comes online, right? So I let you take a guess. What do you think, what is this name? Stephanie, okay, thank you. Will rate Jurassic Park based on whatever numbers you see here. What do you think?
Low rating, 2.5.
Okay, I hear 3 or 2. Somebody who said 3, can I have a hand? Okay, multiple hands. Sir, could you please explain why you thought? She didn't like Avatar, okay. I see. I see. Okay, that is one way of thinking about it. Yes, please.
People who watched the movie Avatar, they gave Jurassic Park a 3.
Okay, very interesting observation. Anyone else? Somebody who said 2? Yes, please.
Same thing there, like both movies Avatar and Jurassic Park are the same character.
Okay. So you said that, okay, since they are similar, therefore if this is true, then that is true. Fair enough. Very nice observations, and we'll actually touch on these pretty quickly in the few slides to come. Many approaches of filling up this number. Somebody, as they pointed out, similar movies, similar rating. Another person watched the same movie, this is 2, therefore this should also be 3. Okay? Somebody might say, okay, this is 1, this is 3, I just take an average, right? 100 ways of doing it, some good, some bad, some better than the others. Here is one estimation using an algorithm which we'll touch upon towards the end of this talk, and its provided rating, which is 4.3. One way to think of it is, okay, you see 2 and 2 over here, 5 and 4 over here. So these 2 people seem to be similar to this person. So this is 3. This should be 3, but a little more because this 4 become 5. So, probably I'm just making this up to make it match to the answer, like we did in school, like we look back at the answer, prove that this is equal to this, 21 आना है, अच्छा कुछ तो करके 21 लाएंगे. That. So, but you get the gist of it, right? And recommender systems had a history of evolution, where we have gone from very rudimentary systems, taking averages, to very advanced systems. And the aim of today's talk is to try to walk you through some of the cornerstone methods that are out there, that are really significant in the industry and produce really good performances. Nevertheless, it would be probably discredit to not honor the roots, which is why I started all the way back from 1 over here, based on simple statistical measures, things like average, or what's most popular. Even today, when you go on a news site like, let's say, New York Times, they have this section where they say, what is most rated, most emailed, most commented, most read, kind of a section you'll see on the right side of the page. So that is using something very simple. It's just, what's trending, what's hot right now. Naturally, as you can imagine, that has its limitations. It has nothing to do with what you are interested in. It is just to do with what the world is interested in. And you might be that maverick who doesn't agree with the world, right? So we also have, then we move towards something called content-based methods. Content-based methods try to bring up content which is similar to content that you are viewing. If you go on Google News, people who have read Google News or still regularly do. Okay, few hands over there, thank you. If you see a headline in Google News, you will see a bunch of headlines that are collected together with it, right? All talking about the same thing, but probably from different sources. So what they're using there is content-based filtering. Typically, text analytics algorithms, TF-IDF kind of algorithms that work well for this. these are very powerful techniques, by the way, in no way outdated and are still used today. But it has its own limitations and it doesn't work for all kinds of content. Which is where we start to move towards what may be called the classical approaches towards collaborative, towards recommender systems. Number 3, which is collaborative filtering methods. I won't spend too much time over here because we'll be talking more about it in the slides to come. And then model-based methods, which are a generalization of the concept from collaborative filtering. Now, stages 1 to 4, at the end of the day, what we might call as academic methods. You open up a book or you go to an online course, these are the kind of methods that they will talk about. Real-world data, as I think most of us here appreciate, it has its own challenges. And what works in a book does not work in reality. So when you go to the real world, there are various kinds of modifications, customizations, heuristics that you need to adopt. Hybrid methods, ensembles. Our friends will probably demonstrate tomorrow. There's an interactive recommenders now. Anybody interacted with chatbots? Okay, great. So you will see some of that, I think, in one of the presentations tomorrow, where, of course, chatbots do a lot more than just recommendation, but it's one of their capabilities nowadays. So what we are going to do is, I'm going to touch mainly on 3 and 4, and we are going to talk a little bit about 5, give you a flavor for it, because this is still way ahead in the future, and we are just beginning the journey towards that direction. So collaborative filtering, let me just explain what the essence of it is. It is similar to what somebody had said, that if Avatar was rated as 2 by someone else, then it must be the same for Jurassic Park because that person rated 3. That is one way of doing collaborative filtering. Another person said,